Chapter 8/8. Okay, functions and graphing, lesson 8/8. The table shows the amount of land in U.S. farms from 1980 to 2000. Make a scatter plot and draw a best fit line for the data. This is the table, the years from 1980 to 2000, and land, millions of acres. Right here we have it drawn. These are the years: 80, 85, 90, 95, 2000, 2005, 2010. And here are the million acres: 0, 900, 950, 1000, 1050. This is the scatter plot. All these points are made to match this table. In 1980, we put the point right here for 1039, 1039. In 85, the point is right here above the 1000 mark for 1012. In 90, for 986, it's right below the 1000 mark. In 1995, for 963, it's right above the 950 mark. And for 2000, it's right here for the 940. We then draw a straight line through the points for the best fit line. So this line demonstrates that we would expect in 2005 for there to be around 920 million acres. Use the best fit line to predict the amount of land in the year 2010. Extend the line so that you can find the y value for an x value of 2010. If the y value for 2010 is about 892, so a prediction for the amount of farmland in 2010 is approximately 892 million acres. We can tell that because this line goes straight down and tells us to make a prediction for 2010. So we check where this line is going to intersect on 2010, and it'll be right about there, about 892 million acres. The table shows the number of laptop computers sold at a local computer store from 1998 to 2001. Make a scatter plot and draw the best fit line. Use the best fit line to predict the number of laptops sold in the year 2003. So these are the points that we have for the years given: 1998, 1999, 2000, 2001, 2002, and then we have the dots put to match with this, the number of laptops sold. We then draw a line, the best fit line that goes through the most of these points. We can then approximate that in 2003, in this year, 650 laptops should be sold. We see it's higher than 600, but less than 700, and we know the point would be hitting right there, about 650. The scatter plot shows the number of milk cow operations in New Mexico from 1975 to 1995. Write an equation in slope-intercept form for the best fit line. Step 1, first select 2 points on the line and find the slope. Notice that the 2 points on the best fit line are not original data points. We've chosen 15, 1200 and 20, 900. Pick 2 lines and then draw the line through them. To find the definition of the slope, we use y squared minus y1 over x squared minus x1, the same definition of slope that we used on the earlier lessons. We have 900 minus 1200 and 20 minus 15, negative 60. Next, find the y-intercept. We know that y equals mx plus b. Y is 1200. M is negative 60, the slope. X is 15, so we need to find b. Substitute that out, and we have 2100 for b. Now we write the equation. Y equals negative 60x plus 2100. That is the answer. Predict the number of milk cow operations in the year 2005. Well, if we have y equals negative 60x plus 2100, we replace x with 30, and we find that y is 300. About 300 milk cow operations in the year 2005. The scatter plot shows the heating bill for the month of January for different size houses. Write an equation in slope-intercept form for the best fit line. A sample answer would be y equals 0.08x minus 1969. We want to pick 2 points on the line and then draw a line through them. If we wanted to draw it straight down like that, that is not a straight line. Do straight up. You choose 2 points. Depending on the 2 points, you will get around a different answer. So for y equals 0.08x minus 19.69, that is a possible answer. If we chose right here, we can choose 1000 and 60 to use this point right there, and then we can use this point also, which is about 3,700 and 300. We find the slope again by find the definition of the slope, y2 minus y1 over x2 minus x1. So we have 300 minus 60 over 3,700 minus 1,000. That gives us 240 over 2,700. 240 divided by 2,700 is 0.088. So the points we used would give us y equals 0.09x. Now, for us to find what b is, we want to use plus b. We can use the points, any of these coordinates, plug it in, and find what b would be. So if we use 1,060, we have 60 equals 0.09 times 1,000. Which is 90 plus b. Now we subtract 90 from 60, and we get b equals negative 30. So another sample answer would be y equals 0.09x minus 30. Because we can use different points on the line to find this, you can have a different answer. Now, B is predict the heating bill for a house that is 4,100 square feet in size. Well, we can just look at the number and look at the line that we drew. If we have 4,100, it's right here. Our line is going through up here, so we know that it would hit right above the 300 mark. So we know the sample answer, about $308.31. We can also plug this into this equation, and that would also give us an answer. If we plugged in 4,100 into this equation, the top equation, you would get y is 308.31. But depending on which y equals mx plus b equation you will get a different answer for this. If we use my equation, we have 0.09 times 4,100. That's 369 plus 30. On my equation, we would get 399. End of lesson 8-8. Solve the system of equations by graphing. Y equals x minus 1, y equals 2x minus 2. The graph appears to intersect at 1, 0. Check this estimate by substituting the coordinates into each equation. Well, we have y equals x minus 1, 0 equals 1 minus 1, yes. Y equals 2x minus 2, 0 equals 2 times 1 minus 2, yes. The answer is 0, 1, 0. You want to solve the system of equations by graphing. You see the graph here. It appears to intersect at 1, 0, so you plug it into the equations of the line. And if they are correct, then you know that is the point that they intersect. Solve the system of equations by graphing. Y equals 2x plus 3, y equals x plus 4. Again, what we're going to do is we're going to plug in this point to see if that's correct. So we have y is 5 equals 2, x is 1 plus 3. Is that correct? Yes. And try it on the second one as well. 5 equals 1 plus 4. Is that correct? Yes. So you know the coordinates where the lines intersect are 1 and 5. One CD Club A charges members a $25 annual fee. After that, CDs cost $5 each. Another CD Club B has no annual fee and sells its members CDs for $7.50. How many CDs would you need to buy in a year for the clubs to cost the same? You know the annual fee and the cost per CD. Write an equation to represent the cost for each club and then graph the equation to find the solution. So let x equal the number of CDs purchased and let y equal the total cost. Y equals 5x plus 25, $5 per CD plus the annual fee. That's Club A. For Club B, the total cost equals 7.5, the cost of one CD, times x, the number of CDs, plus 0, the annual fee is 0. Then graph the system. We can graph these lines and we notice that the solution is 10, 75. This means that 10 CDs are bought. Both clubs have the same cost of $75. Check by substituting 10 and 75 into the equation. We know that that would be correct. Y is 75. 5 times 10 is 50 plus 25. That is correct. And for the second, 75 equals 7.5 times 10. That is also correct. So we know that the answer is 10. The number of CDs would have to be 10 for the clubs to cost the same. Now, which club would be a better deal for a customer buying 20 CDs in a year? Well, for x equals 20, the line representing Club A has a smaller y value, so Club A would be a better deal. We can plug that in to find y, the total cost of 20, if x equals 20. So for Club A, 20 times 50, y equals 20 times 5, which is 100, plus 25. So the cost would be 125. For Club B, it would be 7.5 times 20. Y equals 150. Club A is the better deal. Club A is cheaper. It would be less expensive to buy 20 CDs at Club A than Club B. One film store charges an annual fee of $25 and then charges its customers $5 per roll for film processing. A second store offers an annual fee of $10 and then charges its customers $6.50 per roll for film processing. A. How many rolls of film would you need to have it processed for the same cost to the stores? We set it up the same way as we did the last one. Y is the total cost. At film store A, the price per roll is $5, so 5x plus the annual fee, $25. At B, Y equals $6.50, so 6.5x, plus the annual fee of $10. How many rolls of film would you need to have processed for the cost to be the same? We graph both lines and we find where they intersect. 10, 75. Plug those back into these equations. Make sure that they equal each other. They do. So we know that at 10 rolls of film at $75, the clubs are the same. So the answer is 10. You would have to process 10 rolls of film for the clubs to equal each other. Which store would be a better deal for a customer developing 8 rolls of film? Well, we can plug in 8, the number of film, into both equations and find which one has a lower y value, or we can look at the lines. We can see right here at 8, store B, second store, would have a lower cost than store A. If we plug it in, we have at the first store y equals 5 times 8 plus 25. 5 times 8 is 40 plus 25. So the price would be $65 at the first store. At the second store, we have y equals 6.5x plus 10. We're using 8 rolls of film, so 6.5 times 8 is 52, plus the $10 annual fee. The price would be $62. The price at the second store is less. So if you're going to process 8 rolls of film in a year, then the second store is a better deal. Solve the systems of equations by graphing. Y equals 1/3 x minus 5, y equals 1/3 x plus 2. The graphs appear to be parallel lines. Since there is no coordinate pair that is a solution to both equations, there is no solution of this system of equations. These lines don't intersect. There is no point where the lines intersect. They are parallel lines. This line will continue going down at the same slope as this line. They will not intersect each other, so there is no solution. There is no point that they intersect. Solve the system of equations by graphing. Y equals 3x plus 7, y equals 3x minus 2. Again, we plot these lines. The first one has a y-intercept of 7. The second one has a y-intercept of 2. The slope is 3/1. They again are parallel lines. They will have no point of intersection. Here's -2. This line will intersect at 7. Their slopes are the same. They will not have a point where they intersect. Solve the system of equations by graphing. Y equals 3/4 x plus 6, 4y minus 3x equals 24. Both equations have the same graph. Any ordered pair on the graph will satisfy both equations. Therefore, there are infinity many solutions to this system of equations. So the answer is infinity many solutions. If we rewrite this, we have 4y equals 3x plus 24. Divide all by 4. And we have y equals 3/4 x plus 6. That is the same as our first one. They are the same lines. They have the same coordinates. There are infinitely many solutions. They intersect at far more than one time. Any ordered pair will be on both lines. Solve the system of equations by graphing. Y equals 2x minus 3, negative 6x plus 3y equals -9. Rearrange this so it's in their proper form. 3y equals 6x minus 9. Divide both sides by 3. Y equals 2x minus 3. The answer is infinitely many solutions. Any ordered pair will satisfy this graph as being on both. Solve the system of equations by substitution. Y equals 3x minus 4, y equals 2. Since y must have the same value in both equations, you can replace y with 2 in the first equation. Y equals 3x minus 4. 2, we're plugging in this y equals 2 into that first one. 2 equals 3x minus 4. 6 equals 3x. X equals 2. The solution of this system of equation is 2, 2. You can check the solution by graphing. Now, y equals 4x plus 1, x equals negative 1. All we have to do is substitute this x into the equation. Y equals negative 4. 4 times negative 1 is negative 4. Plus 1. Y equals negative 3. So we know x is negative 1, y is negative 3. End of lesson 8-9. Functions and graphing, lesson 8-10. Graph y is greater than 3x minus 3. Well, graph y equals 3x minus 3. Draw a dashed line since the boundary is not part of the graph. Test 0, 0. Y equals 3x minus 3. Is 0 greater than 3 times 0 minus 3? 0 is greater than negative 3. So replace x and y with 0, 0. Thus the graph is all points in the region above the boundary. We shade this region. Y equals 3x minus 3. Graph y is less than or equal to negative 1/4 x. Well, first graph y equals negative 1/4 x. Draw a solid line since the boundary is part of the graph. Test 0, negative 1, right here, this point. If y is negative 1, substitute the 0 in as well. Is negative 1 less than or equal to negative 1/4? Yes, so we know it is true. 0, negative 1 is a solution, so shade the half plane containing 0, negative 1. Right here, we shaded this portion. Graph y is less than 2x minus 1. It's not equal to, so again we draw the dotted line, and then we shade the portion once we test it. If we do 1, x is 1, y is 1, 1 is 1 less than 2 plus 1, 2 times 1 is 1, plus 1. 1 is less than 3. That is correct. We can shade in this portion. Now, graph y is greater than or equal to 3/4 x minus 1. Y is greater than or equal to 3/4 x minus 1. We draw the solid line because we know it's on this side. We then shade this in once we test for it. 1, 1 will work again. So we have, is 1 greater than or equal to 3/4 times 1 minus 1. Yes, 1 is greater than 1/4, negative 1/4. So we can shade in that top part. Terrence needs 3 cups of flour to make a batch of cookies and 5 cups to make a loaf of bread. He has 30 cups of flour. How many batches of cookies and loaves of bread can he bake? Step 1, write an inequality. Let x represent the number of batches of cookies and let y represent the number of loaves of bread. Cups of flour for cookies, 3x, plus cups of flour for bread, 5y, is at most less than or equal to 30 cups. Graph the inequality. To graph the inequality, first solve for y. 3x plus 5y is less than or equal to 30. 5y is less than or equal to negative 3x plus 30. Divide each side by 5 now. Y is less than or equal to negative 3/5 x plus 6. So example 2, graph y is less than or equal to negative 3/5 x plus 6 is a solid line. Since the boundary is part of the graph, we have this equal to, the line underneath. The origin is part of the graph since 0 is less than negative 3/5 times 0 plus 6 is true. Thus, the coordinates of all points in the shaded region are possible solutions. Here is what the graph looks like. The line goes straight up and down. You shade in this bottom portion. So 0 batches of cookies, 6 loaves of bread, 4 batches of cookies, 3 loaves of bread, 5 batches of cookies, 3 loaves of bread, 7 batches of cookies, 1 loaf of bread. Sue has at most $50 to spend on shirts and jeans. Each shirt costs $5 and each pair of jeans costs $10. How many shirts and pairs of jeans can Sue buy? Well, we know that she has each shirt costs $5. Each jean costs $10. And they must be less than or equal to $50. She has $50 to spend on these two things. We rearrange the equation again. 10y is less than or equal to negative 5x plus 50. Divide each side by 10. We have y is less than or equal to -1/2 plus 5. We then plug in points to see if that's true. We can plug in 0, 0. Is 0 less than or equal to 0 plus 5? 5. Is 0 less than or equal to 5? Yes. So we know that all points underneath this line are possible solutions. End of lesson 8-10. Explore online information about the information introduced in this chapter. So I finished the chapter, and then, so the chapter's done, and then it's just the 5-minute checks, which yesterday he said I didn't want to do, so I'm assuming he doesn't want me to do those again. So 8/10 is the last.
Sure.